In this lecture, you are going to build your first C++ class. Classes are a mechanism we have in C++ to be able to build our own types. If you remember, so far in this course we have been using basic types like int and double, and we were using them like this. We said the type of the variable, we give the name of the variable, and then we initialize this variable, and we can use this throughout our program. Now we are at a point where we need to start designing our own types. Suppose we want to build our own type that models a person, for example. Suppose a person is defined by the name, the age, and the address. And we want to model persons in our program and use them as players, for example. And when we have the properties of a person, we can do all kinds of crazy things with them. We can make them jump up, for example, if we are designing a game. We can make them run. We can make them fly. We can do all kinds of crazy things. In this lecture, we're going to use a cylinder as an example. And we're going to model a cylinder in our C++ program. A cylinder is defined by two things. It has a base radius, which is modeled by this r you see here, and it has a height. And when we have this information about our cylinder, we can really do all kinds of crazy things. For example, we can compute its area, the base area, and the formula to do that is pi r squared. This is a formula you get from your basic mathematics education. You can compute the volume of the cylinder, and the formula to do that is area multiplied by the height. And we can really do all kinds of crazy things with the cylinder if we have this information. So we're going to use this information and model a cylinder we can use in our C++ program. And we're going to be using classes to do that. The syntax to set up your class in C++ is really simple. You say class, this is the keyword you have to put in here. You say the name of your class, in this case it is cylinder as you see here, and then we put a pair of curly braces in place. The start is on top here and the end is down here, and after your class definition you're going to put a semicolon. Inside the class we really have two parts. We have member variables which are going to model the properties that your class is going to have. In this case, we have two properties that really define a cylinder. We have the base radius and we have the height. We have decided to model these things as double types inside our class. And this is going to make the first part of our class, the member variables. The second part is going to be made of behaviors or functions that do things on the class using the properties. And one function we have is the volume function, which is going to help us compute the volume of our cylinder here. If you look at its syntax, it really is a function. We have a return type, we have the name of the function, we have the parameter list, which is empty by now, and we have our curly braces that delimit the body of our function. Inside the function, we're going to do nothing special. We're just going to return the volume of our function here. And if you remember, the volume is the base area multiplied by the height. And this thing here is going to model the base area. You see it's pi multiplied by the square of the radius. And then we're going to multiply this by the height. And we're going to return the volume for use by whoever is calling this function. One thing we haven't really talked about is this public thing you see here. And what this says is that the members that we have in this class are going to be accessible from the outside of the class. For now, we can't really understand this, but when we hit Visual Studio Code, I'm going to show you what this exactly means. Now that we have the class declared, we can really use it like we use any other types in C++. For example, we can head in our main function and set up a variable called cylinder1 as you see here. Its type is going to be cylinder, and notice that this is really a type that we build ourselves, and we can really use it like we use other variables. For example, we can call its function using the syntax here and print the volume. This is going to print the volume using the volume function that we just set up in a minute. If we go down, we can modify things about our cylinder. For example, we can use the dot notation here to change the base radius and change the height. And if we try to print the volume again, this information is going to be picked up and be used by the volume function to compute the volume of our cylinder here. This is really cool. If you want, you can also set up another cylinder like we do here, and we're going to print the volume, and we can really do all kinds of crazy things with our types like this. Okay, this is our class, and we can really use it to do a lot. Before we head over to Visual Studio Code and play with us, I want to bring to your attention that members of a class are private by default. And what I mean by that is that, for example, if we don't put these public keywords in here, we won't be able to use the volume function, for example, like we have used it in our main function, as you see here. If the member is private, it won't be usable outside the class. This is what we mean here. We are trying to use this member in the main function outside the class definition. It won't be accessible if it is private. And we make it public by putting the public keyword and a colon like we do here. Everything after this public keyword is going to be public until we change this to private somewhere in our program if we need that. Now that you have an idea about how you can declare and use your class in C++, let's head over to Visual Studio Code and play with this a little more. Okay, here we are in our working folder. The current project is your first class. You are going to build your very first class in C++. We're going to grab our template files. We're going to copy them and put them in place. And then we're going to open this little guy in Visual Studio Code by dragging and dropping here. This is going to open our folder. We're going to close the left pane here and clean things up a little bit. The first thing we want to do is to declare our class. But before we do that, we're going to need the pi variable, because remember, we're going to model pi for use in computing the area and the volume of our cylinder that we want to model like we did in the slides. So the way we're going to do that, I am going to declare a const variable, and I am going to call it pi, and I am going to initialize this with pi. To get pi, I'm going to cheat a little bit. I'm going to go in my calculator and let's see if I can get pi here. And I click on this and I'm going to grab pi here and copy it. This is the easiest way I can find. So I'm going to put it in here, and this is going to be our variable. Now that we have this, we're going to set up our class. And to define a class, you say class, you have to put in this keyword, and then we're going to say the name of the class. The name of the class is going to be cylinder. And after we do this, we're going to put a pair of curly braces, and we're going to end this with a semicolon. You have to remember this. If you don't put it here, the C++ compiler is going to complain. Now that we have the class blueprint here, we're going to put in our member variable. And these are going to be the variables we use to model the base radius and the height of our cylinder. We're going to put in a double variable, and we're going to call this base radius. And we're going to brace initialize this to 0. We can do this. And we're going to set up another one and call it height. And we're going to also initialize this to 0. Okay, now that we have this, we're going to put functions or methods in our class. And we do that by just putting the function definition in our class. So our function is going to be returning double because it's going to be returning the volume of our cylinder. So it's going to return double here. The name is going to be volume, and it's going to be computing the volume and returning that. Remember, the formula to compute the volume is going to be pi. We have our pi variable on top. And we're going to multiply by base radius twice because the base radius has to be squared. Let's do that and multiply by base radius again. And then we're going to multiply by height. And notice that these are guys declared in the body of the class, if I can say that. This is the definition of the class. We are able to use these guys because we are inside this class here. Okay, now that we have this, our class is really defined, but we can't really use it quite yet. What do I mean by that? Let's go in the main function, and we're going to set up a variable of type cylinder. We can do that. And let's call this cylinder 1. If we do this, and try to compile this, this is going to build fine. Let's do that. We're going to build with GCC. Build finished successfully. This is building, but we have a function called volume here, and we can try and call it using the dot notation that we saw in the slides. Let's try and print the volume of our cylinder here and see what we get. So we're going to say volume. We can say that, and we're going to say cylinder 1 and do volume. Okay, let's see if we can call this function here. And the moment we do that, you see that we have a squiggly line here. So Visual Studio Code has detected that something is wrong. Let's hit the problems tab here and see what we get. It's going to say expected an identifier on line what? This is not making sense. We put 3 columns here. Let's correct this a little bit. And the error is going to change to be cylinder volume declared at line 6 is inaccessible from this location here. This is what the error says. And it is inaccessible because members of a class are private by default. So they want to be accessible from the outside of the class like we are doing in the main function here. Notice that we are able to access them from the inside of the class. You see base radius is declared down here, and we are able to use in the function because the function volume here is inside the class. So the members are accessible even if they are private. But private members can't be accessible from the outside of the class like we are doing in the main function here. That's why we have this problem. Let's see what the compiler says. We're going to pass this through GCC, and we're going to get a compiler error that we expect. And the compiler is really specific in this. It's going to say double cylinder volume, the volume function from the cylinder class is private within this context. And which context? The line 19 when we are trying to use it in the main function. So if you really want things inside the class to be accessible from the outside, you need to make them public and change them from private. How do we do that? It is really simple. You use the syntax we saw in the slides. We're going to say public and put a colon here. And when you do this, it is advised to align your things a little bit properly. So when we do this, everything after this public keyword is going to be public in this class, and it will be accessible from the outside. Let's try and build now, but before we build, let's show you that the squiggly line should be gone. Visual Studio Code is still confused. Let's try and build. Let's pass this through GCC. Now you see that the build is good. Okay, now if we try and print the volume here, we're going to get 0 because the base radius is braced initialized to 0. The height is 0. And if we multiply like this, we're going to get 0 and return that. Let's try and run this program because we just built it successfully. We can bring up a terminal to do that. And let's clear and run Rooster. And we can see that the volume is 0 and it is what we expect. Okay, now our class is working, but there is really something bad about it. And that is because the public keyword is going to make everything public in this class, the member variables are also going to be public. So we can go down here and print the base radius and the height, for example. Let's do that and show you that this is the case. So we're going to say cylinder 1 and say base radius. This is going to print, and we're going to say height. We're going to print this out. If we try and print these guys, let's build and pass this through GCC. You see the build is good. And if we clear and run Rooster, we're going to see that base radius and height are accessible. To show you that this can also be different from 0, let's change the base radius to 1 and the height to 1 to make it a unit cylinder. Let's try and build. We're going to change these guys to 1 and the volume is going to be 3.14 or something. Let's run Rooster. We're going to see our volume here, and we have the base radius and the height. But this is really bad design because the member variables, in most cases, you're going to want to keep them private from the outside because users of your class don't really care about the member variables. They just want to do things with your class, for example, calling the volume function here. So what we usually do in practice is to flag our member variables as private. And we can do that using the private keyword as we do here. And at the moment we do this, everything after this private keyword is going to be private to the class. It is only going to be accessible from the inside of the class. But if we try to access that from the outside, we're going to get the same compiler error we saw before when we tried to access private stuff from the class in the main function here. Visual Studio Code is going to give us a problem saying that these member variables are not accessible from this context here. And if we pass this through GCC, we're going to get a clear compiler error saying that the height and the base radius are now private in the class and we can't access them from the outside. This is really what I wanted you to see, and this is good design. Okay, now that we have our class declared and that we can use it in the main function, I want you to see that it is possible to change these member variables. But to do that, we will need to turn this back to public. And we're going to see a better way to do this later. But for now, let's make them public and show you that we can change things around and make our cylinders a little more interesting. So now that they are public, we can go in the main function and do crazy things, change the data. For example, we can change our member variables to be something else. Let's go down and say cylinder1 and say base radius. We can use the dot notation and put an equal sign and give another value to our base radius. Let's make it 10, for example, and change the height to be something else. We can change that, and we're going to put in a 3, for example. Why not? Now, if we print the volume again, we're going to get another value. Let's copy this and put that down below our changes here. And if we build the program, it should build fine. The build is good. So we can hit enter and clear. And if we run Rooster, we're going to get the volume to be 3.14 first here, the first line here. And the second line is going to give us another volume. And if we multiply these guys with pi, and if we use our formula to compute the volume, we're going to basically get the same thing. Let's try and prove this with our calculator. We have it around. So we have pi in here. We're going to multiply this with 100, which is the radius squared. We're going to put 100 here, and we're going to multiply this with 3, which is our height. Let's put this in, and we have 942.47, which is what we have here. Roughly the same thing. So you see that our function is really computing our volume. We can even go down and change the height to something else. For example, we're going to change the height to, let's make an 8. And print the volume again. You can keep playing with this and really make it clear that our volume function is computing our volume using the data that we have in the member variables. This is the message here. Let's build again. The build should be good. We're going to clear and run Rooster. Now we see another number for our volume. And this is really how you can declare a class. Again, you use the syntax you see here, class. You say the class name. You put a pair of curly braces and you put your semicolon. Don't forget this. Members of your class are private by default, but you can make them public if you want using the public keyword as we did here. Inside your class, you're going to have two parts. You're going to have the member variables, which are going to be properties that define what your class is. And we're going to have functions or methods. Let's say that. And these are going to be behaviors of your class. You're going to go through these functions to make your classes do things. And once you have the class definition in place, you can use it to create variables as we do in the main function here. And the variables we create from our class are usually called objects in C++ terminology. Okay, the class is really a blueprint, and we create objects using that blueprint, and the objects are going to have runtime data that we store in our class. Okay, so for example, if we hit this point here, the base radius is going to be 10 and the height is going to be 8, and that's going to be runtime information for our class object stored in this variable that we call cylinder1 here. This is really what I wanted you to see. Okay, let's try and recap what we know about classes so far. A class can have member variables. Classes can have functions or methods that let them do things. We saw an example of this with our volume function. Class methods have access to the member variables regardless of whether they are public or private. We have seen that. The volume function will have access to our member variables regardless of whether it is public or private. And last but not least, private members of classes aren't accessible from the outside, as we saw in the main function. You can't access them from the main function. You can only do that from the class definition itself. This is really all I had to share in this lecture. I hope you found it interesting. We are going to stop here in this one. In the next one, we're going to see how class objects are built from constructors. Go ahead and finish up here and meet me there.